Sabko namaste. In this video, you will learn three things: making a CNN model using a PyTorch from scratch. Second, using that model in a project. Third, deploying our project on a Streamlit. Okay. So this is going to be a knowledgeable video for you, and this is going to be an end-to-end project. I will explain each and every line, why I'm using that function, why I'm not using that function, everything, every line I will explain to you. So please watch this video. And let me first preview our web app. This is going to be our interface. Browse file. Let me show you how it works. See, it's showing B 92% surety that it's a B image. Let me choose one other image. 99% surety that it is ant. So I have made a same model using a TensorFlow from scratch. If you want that video, please go to my channel and see image classification using TensorFlow. And that video is also a knowledgeable video. I explain line on line. And if you want the same type of videos where I will explain line on line, solving your problem, solving your error, please subscribe my channel, comment, share, and video. So let's get started with our project. So this is our folder. This is our dataset. Let me show you. Train, ants images, and this is bees images. And same structure for the val and the test. Not for the test. I have test mixed images will be there. So let me open this in VS Code. I already opened it. So this is a Jupyter file where we create a PyTorch model from scratch. Basically, this is a markdown which I have already created for my A's. So let's get started. First, I will import some libraries. First, I will import Pandas for the data frame, for creating data frame. Then I will import OS. Then I will import Torch. Then I will import NN. Torch.nn basically from where we can import some import layers and matplot for the plotting purposes. And from torch vision we will import transformer, not from torch utils, from torch vision. Yes, importing transformers. Then we have required also the optimizer, so we will import optimizer also from torch. And thereafter we will import F. This F is for the connecting the models, or we can say ReLU functions is used by this ReLU function. And from now we will import pill for opening the images. See, let me first check that device is GPU or the CPU. For this, we will use function torch dot CUDA dot is available, and device is equal to this thing. If torch.CUDA is available, else CPU, otherwise CUDA. Let me check that our Jupyter file is using CUDA, GPU or a CPU. Let me run it. See, it's working fine and it's using GPU. Now we will define our directories, test directory and the validation directories. First we will define train directories. and same for the validation. Okay, let me run it. Now we will create a data frame class using a pandas. This way you can say this we will create a data frame where we will use two column file name and a class. File name is the name of the image, and class is basically to which class that particular file belongs to. Okay, so our name of the class will be data frame. First we will define constructor for in which it will have a parameter directory. Basically, directory parameter belongs to the train and as well, from where we will fetch images name and their labels. Then second function for creating the data frame will be create data frame. Self, we have two columns. First will be the file names of the images, and it's going to be the empty. And second will be the categories. Categories belong to the class labels, we can say labels of the images. Now we will first for class names in OR list directory, self doc directory, list os dot list directory. We will first iterate over the directory, train directory or a well directory. Okay. After that, basically first we will go to this here, iterate over the this folder. Then we will iterate over the train. Train here will first will went to the end and the p. So here class name belongs to the end. First will be the end, then the b. So after getting into the end folder, we will want to know this class name path we want to know. This way we will joining self directory class name means we will went to this end folder name folder path. After that we have to iterate over this folder. Files name os dot list director this. Here train class path belongs to this. Iterate over this int folder. Then after iterating over this int folder, first we will get the file name. Means in the int, first we will fetch this name, then this name. This way we will iterating over the int folder. After fetching this, if we will appending this file name to the file name list, and then class name will be the int only. This way we are iterating over the ants and the bees directories folders and fetching their name and their class name. Okay, after getting this we have to create a data frame. Df will be equal to pd dot data frame, in which we have two columns, file names and category basically belongs to the labels of the pages, where we are categories is the list. So this way we have created a data frame and returning that data frame. This way our class work is over. Now we will create our data frame you by creating the objects, or we can say directly we are uh, calling the function of training df dot. First we will create the object of, let me make it simple. Object. First we have to create the object of a class. After creating our object, now we will create our data frame training object. Create data frame. This function we will call, and we will get our data frame. And train directory, basically we are passing this one. This. Same for the well. Let me preview our data frame. See, 011 ends. Let me directly print it. See, 0 1 2 3 ends and bees. Means this particular image belongs to the end class, and this particular image belongs to the bees class. Now we will plot images using a data frame. Basically, figure is here belongs to the entire images and access for the iteration over a subplots. I will access in a 2D form before converting into a one. We have to convert it into a 1D. For this, we are using a Ravel function. Now, in range, uh, we want to print 4 by 4, means 4 columns and 4 rows. 16 images we have to print. We have to plot. Sorry, not print. 16. So I did 16 here only. And first we will select sample row from the data frame. Using the function sample. Here we want to select one row only, so n is equal to 1. Okay, this way we fetch one random row from the training df. After that we have to get the image path. For that we will use this os.path join. First we will train directory, basically this train directory path will be there. Then sample row category will be get to the ant or the particular images for the ant or the bee. For that we will fetching that from the category class column. And sample row file name, it will fetch the name of the image. This way first we will went to the train directory. After train directory, uh, for to know which folder we have to go, enter the B. For that we are using this column and selecting the image, which image that particular row, this row is belong, we using this way. So this way we are fetching the name of the image path. This way we are loading the image. And this access, I have told you, this is for the iteration over the subplots. Now we will set a title will be image category, because category column belongs to the label or class, or we can say label of the image. Now plot dot show. See, I think the height is not good. Let me select. This is wrong. This will be 20 by 16. 20 within. Let me do this. See, images are good. B's belong to B's only, and B's and B's. So its data frame, class, columns, and the image file is good. There is no problem in a data frame. This transformers is basically is for the pre-processing of the image. So first we have to create one variable, transforms. Transformation is equal to transforms dot compose, and here we have to create the list of pre-processing of the image. First thing we want that image size should be 60 by 60. Image size should be 60 by 60. And after that, we have to convert it in a tensor because PyTorch basically mostly work on a tensor. So we have to convert that image in a tensor form. Tensor is the value belongs to 0 to 1. This way we have our pre-processing on the image is done. Let me run it. So now we have to create a dataset class. This is useful because when we have to use the datasets dataset loader in a PyTorch to load a data in one variable. At that time, we have this dataset class is useful. Okay, so let me create this. First, define the constructor for the initializing the variables. We will want directory name, data frame, and a transformer if there is pre-processing is there. Initially it is none. Now we have to initialize this. Self directory will be directory and data frame will be this way. Okay, now another function length which return the length of our data frame. Okay, now next will be get. In this function we will basically return the image and the label of it. Okay, so first let me erase it. The parameter is required is the index, means index of the image. First we have to fetch the image path from a data frame. See, this way we have to first is a requirement of the directory, means this to which it is belongs. It belong to train, test, or well. After that, this df.ilog.index. df is a variable. Then we have to ilog is for the iteration over the data frame. Index fetching that particular row. After fetching that particular row, category is basically giving the label of that image. And in this data frame, we have already said that class is also the folder name. So category is after directory, which folder it has to be went. After that, file name means the name of the image. This way we have to fetch name of the image path. Now we have to load that image. After loading that, we have to set uh, the label of that image. So category basically the label. If it is aren't, we have to say 1, else it will be 0. Okay, means all the images for the ant is 1 label, and for the b its label will be 0. Now if pre-processing is required, or we can say pre-processing is not none, then use this. After all things means we have load the images, and also we have pre-processing the images or layer and label is over, and we have to denote the label also. All thing is over. Now just we have to return the image and the label. Okay, so our class is ready. Now we have to create the objects. First, we have to see the parameters is on a class. For the constructor part is directory, data frame, and transformer means for the preprocessing. And all things we need: transformer, train directory, F, and training directory. Now, same for the validation, but the parameter will be changed, and also the variable name will also change. But preprocessing remain the same. Okay, get now for now I want to tell you what is the length of the train and the directory. This tell us how many images for the training and how many images for the validation. We have 123 images for the validation and 2164 for the training. Now we will plot the bar graph which show how many images are there for the bees and how many images for the ants. After getting the column name, count how many string of the ant and how many string of the bees. After that, plot the bar graph. See, near to 1,000 images is for the bees, not ants, not bees, ant, and above 1,000 images for the bees. Now we have to create that data sets using a data loader function. In this line I will show this line basically use the class which we have created, get item function and this len function. So I will tell I tell you that the name should be same which I had given to you, otherwise it will throw error. It is necessary, or I can say torch dot utils from data loader train. We have to pass the train means train object. Then batch size, what I want batch size will be 32. Shuffle means that each batch contain equal number of ant and bees images, and same for validation. Passing the val object batch size 32 shuffle true. So this way our dataset is created. Now I will tell you what is the length of our dataset and what does this mean. 68 means here is 68 batches. In each batch, it contains 32 images, and same 5 batch for the validation dataset, and each batch contains 32 images. Now we will plot the images using our train dataset. Before we have plotted the images using our training DF. Now we will plot the images using our train datasets. Both have a different functions, we can say, and different way of plotting. Train dataset. Typically, train dataset iterate this function till here. It created iterator. After iterator, it will next will give out some images and labels. But each run after suppose I have run first time here. See, let me learn it. Now I have run it, but every time when I run it, the images is different. Let me first plot the images, then I will show you what I want to say. 4 by 4 means 4 rows, 4 columns, and axis is in 2D. I want to be in 1D. After that, for I in range 16 iteration, access and show sample I permuate. Let me tell you what is the meaning of permuate. So before telling the meaning of the permuate, let me tell you one more thing. Let me print the image shape. For that we required a dataset. Okay, let me print it. Train dot get item, index value will be 0. After getting this, dot shape. See, train is object function. We have calling this function 0 parameter. 0 is a index value, and this 0, I have told you, it's returning images on a 0 index and label on a 1 index. So fetching the image shape, we have to use 0 index. Image shape will be 36060. Okay, so basically image shape is uh, channel, comma, height, comma, width. But access dot IMSO required image shape will be HWC. So to convert the shape, we use permute 120. Okay, I have told you the meaning of why we are using permute here. Now we have to set a title of the image also, and title will be the image label. So for that we using this labels I dot item. So let me run it. So let me see what's the problem. Oh, this is a problem. I have not defined it. Now it says okay. See, one, we have already assigned one for the end. Let me convert it. Wait. If labels dot item is equal to 1 is and else. Okay, so this way it's more clear. See, and b b b's. Okay, it means our trained data set have no problem in labels and the images. And one more thing, let me rerun it. You can see the images are different from the previous. So this is because of the next function. Okay, now move to our, now we will create our CNN model, which is from the scratch using a PyTorch. So we have, for that we have to first create a class. It is necessary. It's not like the name should be CNN only. You can cap any name, but requirement is this nn dot module. Its requirement is this. We have to give this. After that, uh, we have to define something. Here we are defining nn module to set that nn module is a base class of our class, so that we can use inbuilt functionalities which is important for our training purposes. Okay, this is a constructor. In this constructor, basically we will describe all the layers which is required for creating our architecture. uh, Let me show you the image of our architecture. So see, we will describe here first convolution layer, second convolution layer, third convolution layer, and flatten layer, and a dense layer. What one thing I want to say that we are not connecting them here in our construction. We are just describing the layers which we are required. In next function, we will connect them. So this is basically PyTorch. In PyTorch we can we have more command on our CNN model as compared to TensorFlow. So let me now first we have to initialize our NN module base class in our CNN model. So the first layer which is required is a convolutional layer. So let me describe it. Here 3 is basically the channels, input channels is 3, comma. 16 here is a filter, number of filters. And third, 3 is the size of the filters, 3 by 3. 3 by 3 is the size of the filter. Now we will require the second layer. What is the second layer? It's max pooling layer. Let me describe it. Self dot pool equals to nn dot max pool 2D, and the size of the max pooling filter, or we can say size of the window size of the max pooling is 2 here. Now third layer is again convolutional layer. So self dot conv2 equals to nn dot conv2 2D. Now see, first layer output number of filter output, or we can say depth is of 16. So input is 16 here. Means second convolutional layer input, that input requirement is 16. And here see, in the convolutional layer 1, in convolutional layer 1 the image depth is 16. Oh sorry, not 16, 3. Image depth is 16, means 3 channel. In second layer, image depth, which is input image depth, is 16, because first convolutional layer is using a 16 number of filters. Now here we are using a 32 filters, and each filter is of 3 by 3 size. Now again max pooling. Here it is pool 1 and it is pool 2, and same size of the window is of 2 by 2. Now convolution layer 1, max pooling 1, max convolution 2, max pooling 2. Now third convolution layer, and again max pooling. Let me do it. Self dot conv3 equals to nn dot conv layer. See, now convolution layer input depth, which is there, is input depth will be the output depth of the previous layer. Here previous layer is convolution 2, output depth will be 32 filters. Number of filters, basically the number of filters is the uh, depth of that convolution layer, or output convolution layer. Output will be the same. Number of filter which is required, which is used by the convolution layer, will be the output of the that convolution layer. So here will be 32 input. It's using 64 as an out filter, number of filter, and size of each filter will be 3. Same max pooling. So we use pool here, pool 3, and size of the window will be 2. Now what we require, flatten. Just flatten will be same. Just self dot flatten equals to and dot flatten. Okay. See, in constructor, we are not connecting any layer here. Just we are describing that which layer which is required in our model, in our architecture. Now after flatten, what we required, fully connected layer, or we can say it is also known as dense layer in a TensorFlow. Okay, and here it is named as linear. See here, linear. We have to describe what would be the output of the convolutional layer 3, so that we can check uh, what will be the dimension of the dense layer for first layer. So for that, there is one formula which we will for calculating, or we can say for describing the parameter of the linear layer is n. So the formula which is required is n plus 2p minus f plus s plus 1. So for calculating that, what will be the dimension of a dense layer, to so we have to use this function. So before this, we have to calculate each dimension of layer output. So first is, see, n is number of input. So here input width is 60, image width is 60. So here it is this plus, what is padding here? Padding is basically, see, this thing. Padding means 0 0 boundary in all 4 direction of an image. Basically padding is used when number of layer in a architecture of a CNN model is high. So to because in each layer process, the image dimension keep on decreasing. To protect the dimension of the image, may use padding, and padding is basically zero value around the image. Okay, this is over. Now, let me, since padding is here is 0, we have not used it, and minus f. Minus f, the size of the filter is 3. The filter which we use, filter size is 3, that's why. Okay, and divided by divided by 1. So this whole thing is one thing. Okay, so divided by 1, we will get 60 minus 3 58 plus 60 minus 3 57, and plus 1 is equal to 58. So size will be 58. 58 by 58. And I have told you the output depth of the convolution layer should be same the number of filter which is required, which is used by the convolution. So here the number of filter used by the convolution is 16. See here. Now same for the convolutional layer. See, after using the convolutional layer, the max pooling is also used. So here after using the max pooling layer, let me tell you, input is now 58 plus, see, padding is again 0, and stride is size of the filter which we use is 2, and stride is 2. Here we are not describing the stride 2, but it is taking a value stride 2, because let me tell you, see, here it is saying that default value is kernel size for the stride, default value it will take is of kernel size, and the kernel size which we have given here is 2. So that's why taking the stride value 2. And what is the meaning of the stride is, let me tell you. See, let me see first. What is if a stride value is 1, it will move the window move to one row only, one row right side and one row on downside. See, so that's why it is stride 1. And for the stride 2, if your stride value is 2, it will move 2 column right side and 2 column bottom. So this way the stride is used. Basically, stride is basically used for decreasing the size of the image, or we can say dimension of the image. Same way, now output will be 3, 29, 29, 60. Now same output will be 27 by 27 for the convolution layer 2. Okay. Now, after using the max pooling, size will be 13 by 13, 32. 13 by 13, 32. Because here see, 32 number of filter 32. Same for the third layer and same max pooling. Okay. 11 plus uh, this all this all calculation is used by this function. Okay. Now flatten is just, see, what is the output? 5564. This is flattened, means converting the dimension, converting the uh, whole dimension into a single row, we can say. Okay, 16,000 cells, or we can say 16,000 neurons is generated now. After this fully connected layer, this we want to calculate that what will be the dimension of the layer after using a flatten. So this is what we needed. So use this here. 64 into 5 into 5. Okay, now how many output neurons we want? We want 256 initial for the first fully connected layer. Okay, here 64 into 5 is an input number of neurons used by the fully connected layer. Okay, now for second one, we need the input number of neurons is 256, and output what we want 128, one number of neurons. Now we want last fully connected layer. We want number of input layer in neurons is 128 and output is 2. Why we are using 2 number of neurons as an output? Because number of classes which we are using here is ant and bees, means 2 number of classes are here. That's why we are putting 2 here. Okay, and one more layer, that is self dot softmax layer. Dimension is equal to 1. Now why I'm using a softmax layer? Because the output is of 2 neurons, and the output is in a logistic form. So to convert this logistic form in a probability form, we use a softmax. And by after converting this values in output values of 2 neurons into our probabilities, when we add this 2 neurons probabilities, the output will be always be 1. So let me tell you one more. See, suppose uh, neuron 1 output is 0.2 and neuron 2 output is 0.8. So logarithm will be converted to, see, after using a softmax, it will be converted to this way. Okay. Now this is wrong. The output of the neuron before the softmax will be in a logistic form. After using a softmax, the output changes to the zero point 0.2 and 0.8, and when we add this 0.8 and 0.2, you will always will be get 1, and you can use this 0.2 or 0.2 as a percentage to watch particular class it will belong. Since in constructor we are just describing the number of layers which we want, we are not connecting here. Now we will connect in a forward function. Here just acts as, you can say, acts as a image as a parameter. Now first, what we want to connect, convolution layer 1, self dot conv 1, passing the variable x here. After convolution layer 1, we want ReLU function. Why we are using a ReLU function? To achieve a non-linearity in our model. Non-linearity means after using a ReLU function, the uh, our model was easily able to learn a complex pattern. If we are not using any activation function, so it will act as a linear way. Okay, so to understand the complex pattern, that's why we use a ReLU functions or any other function. But now we are using a ReLU function here. Okay, now ReLU function. After that, we want pool. Now third layer. Here now, see here we are connecting them. Conversion layer. Okay, then ReLU again. Okay, and pooling. Now commercial layer third. Now ReLU. Now pooling. Now flatten. After third convolution layer, we will use flatten layer. After flatten, fully connected layer. Same after fully connected layer, ReLU will be used. And after ReLU, dense, then ReLU, then fully connected layer 3. And after last layer, we use softmax layer to convert this input value output of the fully connected layer third to into a probabilities form. Now return x. See, this is the way we create our PyTorch model from scratch. I have told you what is the meaning of each and every line, how we have to calculate the dimensions using this formula, why I've used this softmax layer, what is this dense layer, flattened layer. I have told you everything. Uh, okay, this flatten, just converting this output of the convolution layer into one dimension only, and this linear is basically number of neurons. Here 65 into 5 into 5 is 6000, meaning, sorry, 6000 means 1600 images is 1600 neurons is there. Now after this, we have to create the object of this class, which will name them model. Okay, CNN2 device. Here, basically two devices. All this competition which is performed on training, so on during training will be performed on CNN on device, whether it is CPU or a GPU. Let me run it. Now we have to get the summary so that we can say how many parameters is formed, how many layers is here. Okay. Summary. See, here is model, we have passed the object. Here 366 is input dimensions. And see, PyTorch basically always take dimension in this format. CHW means first will be channel, then will be height, then will be width. Okay. See, this is a summary of our model. How many layers? 11 layers is there. First convolutional and output shape 16, 58, 58, which we have calculated. See, 58, 58 into 16. I have already told you the formula which is used for calculating, and convolutional layer output this, and there are 466,594 parameters. Trainable parameter is 4695 and non-trainable parameter is 0. Now we have to define the optimizers. Basically, optimizers is, what is this closest? So first we will describe the loss which we will use here is we use cross entropy loss, and same thing we have to do it to devise this, basically to devise, because model is in suppose model is in GPU by using this two device, but now if I will not use two device here, suppose this will be go in a CPU, so there will be difference that first one thing is in CPU and one thing will be in GPU, so this will not work. So that's why we have to define that to that criteria should be in a device, same device only. Then the optimizer which I'm using here is Adam optimizer, which upgrade our weights values. It's take two parameters, model.parameters and learning rate. Learning rate here I am using it 0.005. Okay. Learning rate should not be, value should not be high and not too much low. If the value is too high, the it will skip the optimal, uh, we can say optimal minimum, optimal loss, or we can say optimal global minima. Sorry, not optimal, global minima. It will skip global minima. If I its value is too low, it will basically learning speed will be very slow. That's why to maintain the speed also, and also that of it not skip the global minima, we will have to precisely define the learning rate value. So here I am using it 0.005. The epochs here I am using is 50. Let me run it. Now here we have to define a model. This is going to be a very good work. This is going to be very uh, fun time, because here I have to define whole thing what is to be done during training part. So let me first describe some losses. Here I'm just describing. I will tell you what their meaning when I will use them. Validation loss, training loss, validation accuracy. This is going to be a list which contain values uh, at every epoch. So let's start the game. Now epoch, in range epochs. Okay. We want first is model should be in a train format, train way. Okay. Now model dot train. After that, I have to describe uh, total equals to 0, correct equals to 0. So let me use some other variables also for storing the training loss of each batch. Okay. Okay. There is no use of total. Let me erase it. Now we have to iterate over the data set, or we can say at each epoch, not at each batch. Data, comma, labels in train data sets. Okay. Now next thing is, since our model is in a GPU, so here also we have to put this in a same device, so there will be no problem. After this, optimizer dot zero grade. I will tell you the meaning of this zero grade. Let me first complete this first part of for loop dot data. Okay. Now we have to calculate the loss. Means prediction is there. Output is the prediction. Now we have to calculate the loss here. Okay. After creating the loss, now we have to use loss dot backward and then loss dot optimizer dot step. See, train dataset. It will fetch first. It will fetch images. Means data is here, images and labels of first batch. Then we have to put them in the same devices. Then there will be zero grade. Means gradient value will be 0 here, gradient value which we have to use for updation of the weights. It will convert the gradient's value to 0. Now here is a prediction. Then we have to calculate the loss. After creating the computing the loss dot backward will calculate the uh, gradient value uh, gradient value using the loss with respect to the parameter. Now optimizer.step move backward to the layer and update the parameters. See here I am using the optimizer.zeroGrid after every batch iteration. After every batch iteration, listen to my words. After every batch iteration, zero dot grade I am using. Basically, it convert the into 0. It is not converting the uh, parameters value uh, to 0. It's converting the gradient value to the 0, because if suppose at epoch 1 the gradient value is something, but if we do not use it, 0 dot grade, and second batch its value will be accumulated. Suppose at if first batch its value will be 0.2 let, and in second its value will be 0.8. So mean is it 0.8, but actually actually its value will be 0.10, means 0.1, means it will accumulate it, but its value will gradient value will become bigger, and its value become bigger, the weights will not be properly updated. So that's why at every batch iteration we have to use optimizer.zero grade to convert the gradient value to 0, so that it perform properly back propagation. Now further, in training loss we have to store this value. We have to store at each epoch how what is our loss. And next thing, what to computate the accuracy, we have to use this dot max output is equal to 1. Basically, this function return two values. First is the maximum value. Second, index value on which the maximum value is there. So here, print is basically the index value. Uh, Now we will correct. Basically, this variable store how many at each batch iteration, how many times our model is correctly predicted the labels of the image. Here print is the index and labels in each labels basically it store the index value. Index value means one. If the maximum value on a one, it means it belongs to ant. If the maximum value is on a zero index, it belongs to b. So to fetch how many correct values it is model is predicted, we have to use this function predict is equal to value sum dot item. Okay. Finally, our this thing is over. Now we have to append this values in our list. First, we have to append training accuracy and how total correction, how many are correctly predicted by our model in each epoch. See, here I am using correction dot plus means here I am uh, adding that in each batch how many times it is uh, correctly predicted. After when all the batches prediction is over, here we have to calculate totally. Totally means all the images. On all the images, how many times the model is predicted correctly. So to calculate that, we have to use this way: 100 correct dot divided by length of the train. Length of the train means number of images. Okay. Same way, training loss. See, training loss here also is training loss is just is here this loss loss here is for the one epoch. One, sorry, not one batch. I am adding loss of each batch. After that, I am calculating for the entire number of images in an image. Okay, so this way we are doing. Now we have to print the masses. Means when the training is completed, we have to show the masses that epoch, training loss, and training accuracy is this. Okay, so this is over. Here epoch 1, 0, 1 means training loss. How we are calculating loss? Training this divided by length of the training data set, and training accuracy 100 into correct total length. See, hard training part is over. Now we have to do a validation part. In validation part, we have to use torch dot no grade. Why we are using torch dot not grade here? Because at validation part, we do not need any updation of the parameters, or we can say weights, and we just does not need any gradients. So that's why we have to use torch dot no grade. Which and one more thing, the torch dot not grade is used at that time when we have to evaluate the model. Now same iterate over the batches. Same devices. We have to see that models and all labels images should be on the same devices. Otherwise it will show the error. Now well dot output. Okay. After that, loss we have to calculate same way that we have to do in this we have done in previous for loop. Then same way we have to calculate the index value on which the maximum value is present. So to calculate how many prediction is correctly predicted by our model during the validation part. Now validation loss. Uh, validation C I have to define. See if I have to done here no training running loss for that we have to define here model we have to evaluate now here we are evaluating the model same correct is equal to 0 and well running loss will be 0.0. Now we have to calculate the we have to store that well running loss will be is equal to well loss value dot item. Okay, this way we are storing the loss value at each epoch. After calculating, now we have to calculate how many predictions are correctly predicted by our model during the validation time. So for that, same function we have to use this way. See, when validation part is over for one epoch, we have to store those values. Same way, just we have done above accuracy dot append. Same way we have to calculate the accuracy and loss we have to calculate the same way. See here this real dilution loss after the for loop is over is just for the batch means batch loss is there, not for the entire number of images in whole data set we have. So that's why we have to do these calculations. Now after the validation part is over, we have to print the business that how our model is going on during the validation. See, validation loss, training loss, calculations is same. So now ready to go, just run it. Now our training part will be activated. So our training is completed. Epoch 1, Epoch 2 till Epoch 50. Our last training accuracy is 98 and validation accuracy is 75. Now we will plot a training accuracy graph, validation accuracy graph, training loss accuracy graph, and validation accuracy graph. So let's start it. We will first create one variable. It takes the values, means how many epochs is we have to iterate. Now same way, fig access is equal to plot dot subplot. Okay. Now access one dot plot. On x-axis we want epoch log, and the line we want for the train loss. So I had before I had told you that what the use of this means. This list basically contain the values of each epoch. This list are using now. We are using now. Okay. Now we want line should be red and straight means straight line will be there, not dotted line. And label we want here is train loss. And same line, but the difference is This will not be train loss. This will be the validation loss. And lines will be not straight. This will be dashed line. Okay. Uh, See, this is not axis. This should be one axis one. Now we will not show any error. And this is not a train loss. This will be the validation loss. Okay. Two lines are plotted. Now we will set labels. This for the x-axis and this for the y-axis. Okay. And for the y-axis will be loss. And its color will be red. Okay. Now axis one dot set title will be. Now we are setting the title will be loss versus epoch. Okay. Now legends. We want legends also. Now straight plot dot show. Okay. This way we have plotted the graph of two lines of training loss and the validation loss. And same thing we want for the uh, accuracy, training and validation accuracy. So here this AX1 will be 2 and here train loss will be train accuracy. Okay, and same here validation loss not validation accuracy. We want color will be blue. Here color will be blue. Labels will be changed. This will be train accuracy and same validation accuracy. Okay, and here this will come to same way 2, same way 2, same way 2. Okay, the title of this will be accuracy versus epoch, and here accuracy for the Y label and color will be blue. Let me run it. See, this is our graphs. This is training loss, this is validation loss going down, this is a training accuracy is going high, and validation accuracy is this much till 73 approx 75. Now we will save the model for our project. Okay, so path to save the model will be give the name of the model and the file type will be pth. Okay, now we will use save here model comma path. Okay, model will be get saved. C and B pth. Okay, now we will load the model again. Model equals to torch dot load path. Load the model. Sorry, here not here. Now we plot the images for the test how our model is predicting for the unseen images. Let's do it. Okay. Now test file name. So it will be os.list director, and we have to give the path name. So let me copy the path name of test. Test basically contain the mixed images of ant and bees, not like this train and the having a different directory. So let me copy this path. Paste it here. Okay. So change this. Now we have to use a transformation preprocessing. We have to since we have already made the transformation, so here there were no need. Now we have to create one list, empty list for the images. Now we have to create one preprocessing. Okay. See, preprocessing, the input variable parameter will be image. Then first we have to perform the preprocessing. So we have to use transformations on the images, image parameter. Now I want to tell you one thing. See, here model is predicting what will be the shape of the data here, this variable will this the shape of this data will have to be same when we giving the variable during the predictions. Okay, when we use this model dot predict at this time, this predict function basically will take the same shape dimension of the variable which is on the training time. So here this data dimension is like let me give you one hint what will be the shape. See, samples, labels. Let me see, the samples will be data only because we are iterating over a data set. See, now print data dot shape. See, the shape of the data is 32 366. It is contain 32 images of shape 60 by 60 of 3 channels. Same shape is required during the prediction. Okay, if the single image will be passed of shape 360 by 60, then it will show error. Okay, that's why we have to uh, expand the dimension. So for that we see here the dimension is before after preprocessing the dimension is channel comma height comma width, but requirement is requirement we have batch comma c comma h comma w. Okay, since batch since it is a single image, so we have to give the shape, final shape will be 1 comma channel will be 3 comma 60 by 60. Okay, so we have to produce this shape for the prediction. So for that we have to use image img dot un uh, unsqueeze. Okay, this will produce this dimension 1360 by 60. Finally, return image. Why have why have just use this transformation pre-processing on the image? Because when we are training the image which is used by the during the training is pre-processed. Same pre-processing have to be there during the prediction, otherwise it will show error. Okay, this thing is done. Now we will plot the images. We want one row of 4 column, means four images of size 20 by 16. Okay, axis is in 2D, we have to convert it in 1D. Variable function is there. Now class names one variable. Since we have already decided that 0 index is for the B and 1 index is for the ant. Comma. Okay, class's name is all over. Now we'll loop. How many times we have to iterate? 4 times, from 0 to 4. range, oh sorry, n will come here. So this is over. Now first we want image path, so image path equals to what will be the directory. This is directory, so we will use variable test directory which we have created before. We have not created, sorry, we have not created that value. So copy this and paste it here. Image path will be this, plus we want to select random file name in this directory. So for that we have to use one library, or we can say package, import random. It will select random images from the directory. Random dot choice from the test. This variable test file name basically contain file names of each image in the test directory. So from this we have to select random file name. See, now image path is completed. We have to load it. After this we have to require pre-processing on an image. Okay, now finally we have to predict. Preprocess image plus 2, because our model should be in different device and processed image should be on different hardware, so it will be through an error. So that's why to revise you have to reuse. Now pred will be equals to dosh dot argument max. It will give me the index value on which the maximum value is present. Okay. Now label equals to class names spread. If the maximum value on 0th, it will be b. If the maximum value on the 1 on output, it should be ant. The image belongs to the ant class name. Now access I dot I'm show image and access I dot set title. It should be label. Finally plot. Let me run it. No such a directory. What switch directory? Okay. Oh, one mistake. This slash button. Slash is left. Slash is required. Now run it. See, B for the B, and this is B prediction. This is B. Somewhere it is predicting code. Let me rerun it. And wrong B. Similar to B, that's why model is predicting it B. It is B and it is B. So working well. Now we will use this model for our project and in P classification, and also we will deploy that model. So for that we use a Streamlit. So let's get started and make our Streamlit file. So let me first make the architecture. So first will be model, then we want one for the classifier. Okay. Okay, this is done. So let me put this files, this one and this one, this one in model. Okay, this thing is done. Let me create one main file for the Streamlit. Oh, sorry. Before that, we have to install Streamlit. I already installed it. That's my requirements already satisfied. So let's get started. Okay. Now, still first thing will be have to title and layout of our web app. So set page config, and in this first will be the page title, what we want, ants and bees classification. Okay, this is done. Now second thing, what we want, layout will be centered. See, this is done. Now we have to set the background of our web app. Set background. Okay, in this we have to give the path of the image. Let me first create one folder in which we will utils. In this we will create one file known as util.py. Okay. Okay. It contains basically the helping functions. Uh, Sorry, this is not. Let me create again. We have to import Streamlit and one more thing, import base64. Then define the function for the background. In this, we want image path. Okay. Then we have to open this image path. In read mode. We will get the image. We have to now encode it in B64. For this, we have to use base64 dot B64 encode and image data dot decode. Okay. Now style equals to f this way we have to define this. So style style dot set app two curly brackets. First will be the background image. URL will be data is image in PNG and base 64 comma curly bracket B64. This variable we have to pass. After that, this one. Now we have to define background size should cover whole screen. So for that we have to use cover here. Now this thing is completed. After this, we have to close the style. This is over. Now st dot markdown and style dot unsafe for true. So this is our whole function for the setting the background of our web app. Let me save it and make one file. init.py so that we can easily call this function from into our main file. Dot util from import set background. Save it and go to main file and call this function from util folder import set background. So this way we have imported. Let me close it. I will pause this video to get back with the image for our background. So this will be our background for our web app. This, let me put this in util folder, copy the related path and paste it here. Now everything is done. So let me check that this is working well or not. For that, we have to use one command, Streamlit run main.py. It's not displaying anything. So spelling mistake, it should be ST, not SET. Save it and run it. You will see the background. Let me refresh it again. See, it's showing the background. So now we'll make a main file. Okay. Now we will make a CSS for the header and a title. We want text line should be center. Text line should be center. Font size should be 50 pixel. And color which I am using here is hash f0 f0 f0. So let me pause the video and come back when I will complete this CSS part. Okay, so wait for 1 minute. CSS is ready for the title and the header. Text line center, font size 50 pixel, color this, font weight, bold, same for the header. So let's first we will make title. For this, we use div here whose class is title here. See here CSS title class is now, that's the same name. title. Oh, this is a mistake here. Okay, over. Let me put in this way. Now it is okay. What will be the title? Title will be ANTS, ants and bees classification. Now close the tape. Our title is ready. And after this, unsave. This basically activate the HTML part. That's why we are using here. And same for the header. Let me copy this whole thing. Okay. See, header, same class name will be there. Okay. And for header, we have a different string. We are using upload an image to classify it as an intent B. Okay, so this thing is over. One more thing, this title is the title which will be visible on the web page, and this title basically this title will display on a tab above the tab. Okay, so this thing is over. Let me go to the browser and first we have to save this and go to the browser and refresh it to see that it's working or not. Oh, it's an error. Let me see. Unsave title. What's the difference? Close the tab. Tab is also closed. See, this is a mistake. Now save it. Go to the browser and refresh it. See, it's working. Okay. Now may make a input which will browse the files from the computer. For this we have used file uploader. Nothing will be displayed. Type which we want here is we want JPG file. JPEG, PNG, and one more file that is JFIF. Okay, so these are the extension we can say for the images. Okay, now we will load the model. For loading the model, we have to import torch here. Okay, so model will be equals to torch dot load and give the path of the model. Model path is copy related path, paste it here, convert the slash this thing. Our model is ready. Now we have to create one more file here, the text file, which will uh, just let me don't create it. Let me just use this variable. Class names equals to dictionary. For 0 index, it will be B, and for 1 index, it will be int. Okay, this way we have created the class names variables. No need to take create a text file in a model. So this way, if now if suppose a user upload the file, if file is there is not done, then first load the image file and convert it into RGB. This image should be capital. Now go to the above and import image package from build. Save. Now it's done. Okay. So why we are converting this in an RGB? Because in this function basically read the file as a binary string. So to convert it to its in a RGB, we have to use this function convert here. So after converting, we have to now use one function which we will create in a classifier folder. Classify. In this function, we will pass first. We will pass the image, loaded image, then the model, then the class names. Okay. Now we will go to the classifier and one make a Python file classifier.py. Okay. So import dot share def classify. The first parameter is which we have to give is image, then model, then class names. Okay, this thing is over now. So see, I have told you during the training part only and during the prediction part only that the what type of the images or what dimension of the images the model is using during the training time. We have to give the same dimension or the same type of the image during the prediction only. Otherwise, it will show error. So first thing that we have to do during a pre-processing is transformation. So here also we use transform. Let me first import it. Compose. Now we will create a list of the pre-processing. First, we want transform.resize, and resize will be of 60 by 60 because the input first on the first convolutional layer, the input size which we have given is 60 by 60. That's why same here. And after that, we want to convert that image in a tensor form to tensor. Okay, this way it is converted. After pre-processing is done, now image is equal to transforms image. See here the size of the images, sorry, shape dimension is like this. Channel after preprocessing, channel height and width. But model requirement is batch, comma channel, comma height, comma width. So to get this dimension, we have to unsqueeze it, or we have to expand it. And squeeze 0. Okay, this way we will get this dimension. After this, we have to set the device also, otherwise it will give error if something is in GPU and some other thing is in. Okay, that's why. Device is equal to torch dot device if CUDA if torch dot CUDA is CUDA dot is available. Okay, else CPU. Erase this, no need. This way we have get the device also. Now we have to place all thing in same device. So image will be equals to image dot to device, and same for the model. Okay, now everything is done. What spelling mistake? Oh. DE device. Okay, now we have to perform the prediction part. Prediction will be equals to model image. Here the dimension of the image is batch size CHW. Okay, in batch it is given here 1, C is 3, and H is 60, W is 60. Now we have to fetch the index value on which the maximum value is there. 0 if prediction. So what is this? Some donkey. Okay, wait. Prediction 0, 0 if it is greater than 0.95, else 1. It's getting complicated, so let me make it easy for you to understand. First is score, comma index, and we will use the function max. Okay, so np.max, not np.max, I will use torch.max. Okay, it gave me both the things, score also and index also. Prediction and access will be dimension will be 1. So it will give me score, the maximum value in that prediction, and also the index value on which the maximum value is there. So now we have to predict, now we have to get the class name of the image. For that, we already fetched the class name dictionary in which we have decided that 0 for the b and 1 for the ant. So we have to use here class names and index. We will get the class name of the image. Now confidence score. Since we got the score, it is in a float variable, so, float type. So we have to be converted in an integer type first, so that we can easily display it. Confidence score. It should be int and score multiplied by 100. We will get the percentage value, so that how much it particular image belongs to the ant and image. Oh, sorry, ant and the bee. So after that, now work is over. We have to return the class name and a confidence score. This thing is over. Transforms. What's the mistake here? Transforms is not used. We have used here transforms is equal to transform. Image transform dot compose. This is because variable name and the package name is same. Okay, same thing here. Now it's okay. Save it. Now again we have to make edit file. Spelling mistake. Let me correct it. Done. Now from dot classifier import classify. Go to the main file, import this function from the folder, import classify as a function. Now we will get prediction and the score. So now we will create a HTML part or a CSS part to display our images and a confidence score and a prediction class name on a web app. So let me code it that part and come back with the video. Okay. So this is our CSS part. This way we are displaying the image. It is a score and a score. See here, this image.bsc. It is a converted image. See here, the image is in RGB format. No, but for to display the image on a web app, we have to convert it in a or encode it in a byte stream to display it in a web app. For this, we have to use this 3-line code. Buffered byte ID, the package. We make our object here, we save it, and we convert it. This way, we convert the image into a byte stream to display it on a web app. Now, our whole code is ready to go. Save it and run it. See, it's showing an error. See, can't get attribute CNN on module main. See what this error is saying. When we are loading this model, this model thought this file basically contain uh, one keyword in it is CNN keyword, which the basically is a class name which we have used during the training part, which show the architecture of our CNN model. Okay, so we in this time on loading time, the CNN model, the CNN R keyword getting an error that where is this architecture, where is this architecture of our CNN. During the saving time, it not save the architecture of the model. Basically, it save just a class name, or we can say class name as a keyword, as a reference of an architecture. So here we have to first create the cnn.py file. This way, just copy and paste the CNN class and import the libraries. This way we have created this. Then we have created this interpret to load it in our main file. Okay, same way what we have done to this utils and model. Okay, so this is done, ready to go. Let me import it. I think yes, let me import it. Okay, now we have to run it or refresh this page. This is a web app. Let me browse the image. Let me choose from the test. Let me choose this one. See, it's working well. Let me choose one other image for the end. Yes. See, our model is ready, our project is ready. Now we have to deploy it. For the deployment, we have to make requirement file, requirement.txt file, in which we give the libraries and their model name. Oh, sorry, not model name, version name. And second thing, we have to make a GitHub repository. Then we have to deploy it. So let me pause the video and come back with the requirement.txt file. Okay. So this is a requirement file with the libraries and their version name. And one more thing, changes is required here is this thing. Map location towards device CPU. Why I'm using this? Because uh, when we are saving our model during training time, after training time, at that time our model is in GPU and all things in performing in a GPU. So when we and now we are where we are deploying it, there all function has to perform on CPU. That's why I have to use map location torch device. It will convert the location from GPU to CPU. Okay, and doesn't show any error. So save it and go to the GitHub repository. This is my repository. Click on new, make ants versus b image classification. Okay, uh, add readme file, git repository. Then after this, upload the files. See, folder will not be uploaded. It will not upload the folder. So to upload the folder, we have to do something else. Let me show you what we will do. Commit changes, add file, create new file. First, we will make model folder. In that, uh, just make it. Okay, we will delete it afterwards. Commit changes. This way, we get the folder model. Go to the folder and add file, upload files. Go to the model folder and select all. Please make sure that you have to upload this init file also. Do not skip this. Open. Okay, commit changes. After this, go to the model and delete this a.v. a.xp. It's not required here. We had just make it to load the files. Okay, this way. Now commit the changes. Okay, same thing we have to do for the classifier and a util folder. Let me do it and come back with the video. So I had created this repository with folder and the file names in it like this. Now you have to go to this website, share streamlit.io, continue to sign in, connect with GitHub. After I already signed it, that's why no Windows come that authorization go to the email and OTP. This whole thing is not done because I have already done it. So you can go and done all the conditions which is required. This there is a tiny. It will take only us minute to do it. Okay. After that, you will get this interface. Create app, deploy, give a repository name. We have this repository. Our main file is of this main.py file. Change this. Okay, this is good. Let me see if it will accept this or not. Yes, it will not accept this. This is good. And then B. Let's deploy it. Start deploying it. You can see here. What's import torch? No model name torch. What is the mistake here? But we have requirement file is there. What is the mistake here? Let me see. Oh, same mistake. This file name. Let me edit it. Yes, okay. Commit changes. Commit changes. It automatically check. Now it's installing the libraries. Error installing requirement. Let me check and come back. See, I have solved the error. The error is of Python version. So go to the setting part and change here. I am using version 3.10. So select this 3.10 and save changes. Okay, and it will automatically work. Let me pause the video and come back when all the process will over. It will take time. See, after all the things get over, you will get the step interface. Let me check everything is working well. Let me select this image. It's working very good. Our development process is over. Now I will show you how you will get the link. Close this, share, copy link. Link is copied. Cross this. Let me paste this in this. One important thing I want to say that to know that which version you are using of each library, you just uh, pip use this command pip show. I want to know that which version of torch I am using, so I will write torch. This way you will get your version. This copy this and paste it here. One thing is left here is numpy equals to this. Oh, sorry, this was not. Let me take it from here. Numpy version is this. Okay. Forward. So this by using pip show command, you can get a version of any package which you are currently working, which you are currently using. So, and one more thing, after deployment, you will have one functionality like if you make any changes in your GitHub, it automatically update in your link. Okay. Now I will tell you this. Open. Let me open this one. Okay. Let me close this so that let me show you more. And since I have get the link, copy it. I want to open in this in different browser. Let me open this in Edge. That's to see that it's working well or not. This our project is deployed properly or not. See, it's working very good. Nicely, it's working. It means our project is properly deployed. See, now in this video, I have told you how to make a PyTorch model from scratch, explaining the each and every line, why I'm using that line, why I have used that function or not. I make a project using the model which I've created using a PyTorch from scratch, make a project, then deployed it also. So this is a very good video for you. Now my next video is on a object detection. To want this type of explanation, explaining each and every line, explaining why I'm using this, why I'm not using this. So to know why each this type of videos, please subscribe my video, share my video, and like my video. And my next video is on object detection with project. So continue. So, thanks and goodbye.